Okay, just a few points to note. First of all, the super class constructor call there may be, of course, be preceded by a reference to an instance of the superclass's immediate enclosing class. Okay, now if you don't supply one, what happens is it sort of uses the closest available class from the enclosing classes of the current class. You see what I mean? It traces back up through the series of this $n and so on, right the way up the tree until it comes to one that encloses the superclass that you're trying to instantiate. Okay, and of course it'll do that provided the superclass is nested somewhere and it's not static, so it actually needs an enclosing instance. Okay, it is of course never preceded by a class name. You should never see class name in front of something like that. It's got to be an instance of something. Now, when super and this are used to access members, they may be preceded by a class name, okay, and they are never preceded by a reference. Okay? And a reference this, of course, will actually give a compiler error. Now, here's an example of various combinations here. Well, there's two examples. There's one down here and there's this one. We got out here, which has got inside of it class in. We've got son of out, which just extends out, and son of in, which extends in. And here, for example, is a constructor for son of in, and all it does is pass itself onto the super constructor for out.in, and that's going to require an instance of out. And so it supplies one. You might say, well, that's not an instance of out. Well, it is, because son of out is a subclass of out, so that's perfectly good as an instance of out. So new son of out certainly will work. And here we're passing in an actual reference to out and using that. That's equally good. Now if we look at this, son of in is a variable there, and we can create it like that, which will trigger that one there to run. Or of course we can do son of in and supply it with a new out, which we'll call that one there. Or you can do son of in and supply it with that, which is equally valid, because of course son of out is of course of type out, so that's equally valid and satisfies that. Right, now let's have a look at something else. Supposing we've got package here with class out in it, and inside it is class in, and it is protected. Then if we have package 2, which is son of out and extends one.out, so it extends that. We'll put the package name in front here to make it distinct, because we're not in the same package. Then the following here will generate a compiler error. You can't then say new in. You can't do that because although you've got access to in there, you haven't got access to the constructor. And the reason for that is if there's no constructor specified, then the default constructor is going to have the same access rights, the same access protection as the class itself. So the constructor for in there is going to be protected. And that means, of course, they can only be accessed by descendants of in. And now we're in a different package here, and you can't descend from out and be able to access the class name, and descend from in as well and be able to access the constructor. So that makes life a bit difficult, so you can't actually do that, of course. And of course, to say something like new in, of course, you've got to have access both to the type, that's in, so that's got to be available, and also you've got to be able to access the constructor. Okay, and those are two different things, and you can't get both in a separate package like this here. Okay. But a class cannot extend any class that it encloses. So for instance, if we got out here, you can't have it extending out.in. The reason for that is fairly obvious. Any constructor for out, okay, requires that the constructor for in runs first, and in requires an instance of out for its constructor. So you can't do it, basically. And in Java, in fact, the restriction is even stronger than that. No class can even indirectly depend on itself. For example, here we've got a class out which extends ext, and ext extends out.in. Okay, and that will produce an error because out extends ext, extends out.in, and therefore out depends on itself, basically, because it depends on out.in. So that is not allowed, even though this class in here is static. So in fact it doesn't need an outer instance, but it still fails to compile due to it depending on ext, which depends on out.in. So the restriction is tougher than it actually needs to be, but that's not, in practice that's not a problem. And in the above case, for instance, if you take the static class out from there and put it separately as something else, it will actually compile fine. And of course that shows that the restriction is a lot tighter than it actually needs to be.